So he's going to need to do something to snap. Just over these. Okay.
Something's happening. It's not. I can see it on here.
So you're not going to.
Oh, I just saw that.
Thank you for coming. Please take a seat.
Like when someone's talking.
And all right. Welcome to the Association for Computer Machinery. Links to be able to join are over on the other board. There are also meeting times for a couple of the committees that we have. Apparently pressing 0 makes it stop. All right, so first we'll have reports from our committees, and then we will have a presentation on machine learning. So first off, just want to recognize our guest speaker, Brother Burton. I always want to say Barton. All right, and so the Projects and Activities Committee. Do we have a representative from here today?
Doug is sick today.
Is he? That's a bummer. All right, the Online Committee.
So we were able to get a site up and running. It's at BYU-Idaho.acm.org. Looks really good. Product. This is mainly as a place to learn while we're developing our own website. We have our meetings every Monday at 5 o'clock and then 2 to 12. No experience is necessary. It helps, but I don't have any, so we'll learn together. Also, too, we're looking for someone who can be the social media voice of the association. So would anyone be willing to do that for us? So just the meeting comes on Monday, and our assignments throughout the week. It's not. I mean, you talk to the people that have been in it, maybe 30 or 45 minutes outside of the meeting. So just depending on how big the project is. Yeah. Any other questions? Okay.
All right.
Oh. See me after if you want to be the social media rep.
Yep, just need the heart moving, right?
Yes.
Okay, so the Artificial Intelligence Committee. We are meeting on Tuesday at 11:30 p.m. in Austin 210. And we'll be having a presentation on some AI concepts given by one of our committee members. And as a group, we're working to build a working AI for a site called the AI Games. It's a template, it's a starter bot, but basically what it does is it plays risks. So it makes strategic moves, like gets a feel for what the other player might do and tries to overcome the player. The game itself is called Warlight. It's a little bit different than Risk, but it's really fun. It's really cool. You guys should come. And again, all we really want is heart and willing minds. We have people of varying experience levels all learning and growing together. So yeah, please come to that. The Code Challenge Committee. I don't think he's here today. Hayden is not here.
But you can see the code challenge on the website. It's on the website now. Awesome.
Okay.
And it's an ongoing thing. We're definitely going to start ramping things up soon with code challenges and so forth. Stay tuned, but you can check out what we got for code challenge on our website.
Sweet. All right. With that, I think we can move into our presentation. That's what we're doing. It's just a secular, so there's a cool thing that okay, hold this up. So we'll have to check and see how this works here, Matthew, but I want to
I want to share my projected screen and not my desktop here. You know what I mean?
Yeah. Click on that.
So if I do this,
I think you're not extending your desktop.
well, that's the trouble is, in order to do so, I need to do this. Present. And maybe if I come back here,
Yes.
I think that's the right one. I am screen sharing.
Yep.
Is that coming through? Okay. Excellent. So I'm happy to be with you today. I'm I know many of your faces, but there's a few here I don't. And I want to talk to you a little bit about machine learning today. Give you an introduction to it. And hopefully we'll remember it in your class or something like that. But a little bit about me. I have been here at BYU-Idaho for about 3 years now. I did my PhD in computer science at BYU-Provo, and my research was in machine learning and data mining. And I'll highlight some of the things that we did. So this is stuff that I love and that is interesting and exciting. So I wanted to start by asking the question, what is machine learning? We'll talk a little bit about AI and machine learning and what is this? Because we have this kind of natural progression in mind, I think, when we think about computers. So, you know, we start with simple things, and then before long, we end up with these big computers in rooms like this. And of course, the natural next step is this. And then pretty soon, the computer is, you know, smart enough to take on chess champions and doing things like this, right? And then that lasts until now computers can beat champions at Jeopardy and some of these maybe there's some interesting challenges to a task like that. And then from there we start building other things, right? And then pretty soon our robots look like humans, and then before long they're taking over our jobs and everything. And so, you know, there's kind of this interesting idea about machine learning or artificial intelligence. This actually brings up an interesting question here. The grandma is fond to quote somebody else that say that anyone that can be replaced by a robot should be here. Any job that can be replaced by a robot should be here. And so, you know, as we think about this, to understand what is our role in this future world that gets created, is this kind of what we're looking at, or are there other things that are going on in machine learning? So I guess, what would you guys say if I asked you the question, what does it mean to be intelligent? Or what does it mean to learn? Anybody have any thoughts for that question? Answers? Yeah.
So when I was chosen for the AI control, this is a question I asked myself.
Good.
And so I did a lot of Googling, and kind of the first thing that I decided on was that there are two things we talk about when we talk about AI. And those are being tested. There's artificial intelligence, which is decision making, and machine learning, and artificial consciousness, which I don't know if we're really into. Okay? So intelligence, as far as I understand, is the ability to make choices based on your evaluation of your life.
Yeah, okay, so it's choosing between two different things. Now, but if I had an algorithm that just chose the first thing every time, you'd probably say that's not very intelligent, right? But it would be making a decision. And so, you know, so there's thoughts that kind of go on here. And what's happened is there's been different levels of questions that have gone on over time. You know, AI has kind of evolved over the last several decades. You know, because people used to say things like, well, computers, they aren't intelligent. If they could beat people at chess or fly airplanes, that would be intelligent, right? Now what do we have? Computers that do those things, look at it and say, oh, well, it's not really smart to be a chess player. It just has a big database. And so, as you look at these things, sometimes those questions are interesting, and we talk about some of those with regard to creativity as well. I'll show you some thoughts on that. But when we talk about machine learning, typically we say if all a machine can do is recognize and repeat back to you exactly what it's seen before, we're using the database, nice query database, you get it. We would tend to say that it's not really learning anything like that, right? It's just recording and recognizing. When we talk about machines being able to learn, usually we're thinking about the ability to adapt to new things or to generalize from, okay, I've seen this situation before, I haven't seen that one, but I'm going to take the principles that I learned from over here and extrapolate or apply that to a new circumstance that I've never been in before, or something that I haven't seen before. There's always this discussion about AI versus machine learning, and there are probably canonical descriptions of each of these that you should go find and see. In general, when people talk about AI, sometimes you'll hear a term called big AI. And that's where people are talking about some of these ideas like, artificial consciousness, and some of these kinds of things. And these are great questions, and I think they're really interesting ideas to study. But what's happened over the years is that machines, I guess you would say, many people would say that machine learning is like a subset of AI, where we're interested in applying some of these principles to very specific domains. But there's other research being done in AI. I wanted to show you at least part of a video that's kind of interesting. So, and this is about Pierre. This is a project that I did as a graduate student. I took a graduate class in computational creativity. And many of the same questions that get asked about intelligence get asked about creativity. And we say, well, what does it mean for a computer? Can computers be creative? Or do all they do is they just do more than zero based on what the programmer did? But what if it comes up with something that I didn't know how to do? What if computers paint? What if I gave you two paintings and I didn't tell you one of them was from a computer and one of them was from a human, and you'll just, oh, those are interesting paintings. Would that computer be creative? Well, so Pierre, let's see if I can do this. We have this up here. Okay. So this is, like I said, a project that we did and that was featured. So this was my professor for that class. So here's Nanny from BYU-Idaho. She went and taught to Dan Ventura, who's a professor at BYU. And his research area is computational creativity.
Yep. His name is Pierre. Pierre. So we know
okay, so not gonna lie, we totally came up with the name Pierre first, and then tried to figure out the acronym to make that work. But we wanted to come up with a system that could generate novel recipes, things that nobody had ever tried before, but hopefully they would not just be like, boiled tennis shoes or something, but it would actually taste good, right? And so we went out and we, part of machine learning is often that you start with some set that you understand a little bit about. So we went out and we pulled recipes from online recipe sites. We said, oh, these are probably pretty good recipes. And we said, can we learn from these? Hey, anytime it has these ingredients together and those ingredients together, maybe that kind of works. And we tried different things. Anyway.
One way to say about that is, what can we do to make the computer more like I'm interested in anything creative that you probably think people have compose music, paint art, create recipes, whatever you need your creativity for. It's fun to think about. Can we have
How does it computer learn to cook?
Well, kind of like people learn it. It looks at thousands of recipes and learns what makes a good recipe and what makes a bad recipe.
So pointing out that of course we didn't put this crazy computer sounding voice our system. This is all for like children. But there's a lot of that sometimes that goes into AI and machine learning. When the presentation of it is actually really pretty important to get people to do it. There's something going on there. So part of that we came up with. This was a fun. It was almost like an afterthought that I put in these recipes. It was a really simple process. Took two of the main ingredients and kind of grabbed it adjective to go with it, or end up with heavenly bacon, tomato cacciatore, and you say, wow, that sounds awesome, right? But it was really fun. People like that.
It does, but it's very constrained. It seems funny. Some of them are kind of funny. Often they're pretty odd. It's just a very simple template.
Putting all these recipes together on the computer, what would your goal?
What we want is tasty recipes. We also want the recipe.
Right.
Things that are surprising, things you might not expect to be good, but as much as possible, we want the computer to be area to come up with a unique, tasty recipe and somehow know that it's done. So that it can feel confident and they might like it being blend.
See, and so that's actually a really big part of some of these kinds of processes, is to not just be able to throw things together, but be able to have a system evaluate it and say, I think this one over here would probably be better than that. But let's kind of work in this space a little bit. How does the computer quantify the goodness of a recipe? Right? That's kind of an interesting. So part of a project like this is this like generating stuff based on what we've seen before. But in order to do that, we also had to like, well, let's see if we can predict the quality of a recipe.
Vegetable broth, everything would be in a simple soup. And then it throws in jalapenos, and then which will be very interesting to see what they look like in one pot.
It's so hard to believe that the computer could turn out a recipe that would taste good.
Well, it didn't start out tasting good. So after we heard some of that, I got it really try it, and people said they did like grass.
Yeah, so we kind of had a midterm presentation, and everybody's like, ooh, grass soup, good job, right? But then toward the end of the semester, it actually turned out pretty well, and people liked it and came back for seconds and things like that. Well,
I've never seen a recipe like this before. Yes, it tastes what matters. We'll find out.
We have a couple of dietitian students, April and Aubrey, who cooked up one of our dishes.
We picked the broth of joy. Here's joy. Excuse me. Here's joy.
And you must actually taste it in the shot.
Let's try it.
It's actually yummy. I can't believe it. It actually tastes like a hamburger stew. I love the beans. I love the chickpeas. The hamburger tastes great. The steak kind of ducks it off.
So anyway, now you can imagine that whenever we have chili cook-offs in my ward, I always have to bring a PR recipe and try not to win, most likely to have come from a computer or things like that. So, there's some fun things going on in the AI space and machine learning. And computational creativity is kind of an interesting area of that. But typically, when we talk about machine learning, and when we look at some of the real success stories of what computers have been able to do really well in the machine learning space, it's been less about this idea of big AI. Things that we do in the 70s, people were really big into this idea. And now we look at it and we say, computers can be trained on very specialized tasks and do really well in those. So, for example, an example that I look at a lot is something that machines can do really well. You guys want the lights on or off? So if we give the computer a list of, let's say we work for a bank, and we know all the loans that we've given out over the years. And we say, okay, we know which people paid those back and which people defaulted on their loan. And so we want to try to learn that pattern. So in the future, when someone comes in who we've never met before, right? This is just adapting and generalizing to a new situation. So when Jay comes in, and I've never met him before, and I can say, well, let me ask you a few questions. What's your credit score? What's your job history? And then I can say, well, I think you're going to be a lot more like the people that have paid it back. So I'm going to give you the loan, right? And so in a way, in a presentation, sorry, go ahead. That's right. Knows things about you because it's difficult. But there's some interesting things here, and I hate to be the one that like. I knew someone once who said, I was so excited about artificial intelligence and machine learning, and I wanted to go into this for graduate school, and I went and I sat in on some of the first class, and it turned out it was all a bunch of statistics and probability. I was like, that was boring. And so, like, yeah, so I went and did something else. And I think that there's kind of this like aura of mystique, magic around artificial intelligence that we look at and we say, oh, that's awesome. The computer is learning. And then you start to get into some of these algorithms, and you're like, really? It's just statistics. It's just the most likely probability, and that kind of turns out to be boring. So we're gonna kind of take some of the magic out for you, and I hope that doesn't ruin it. But you know, computers are really good at churning through big data sets like this, right? And saying, okay, I've got all this, and what can I learn from this data set? Right? Because this will say to me, oh, these two defaulted on their loans, these ones repaid it. So what is there about these? And we can ask questions like, how similar are you to these people? And we start looking at this data set and we learn what? Don't loan money to people named Steve. Right? Because in both cases, there was somebody named Steve who didn't repay the loan. So you have to be a little bit careful, right, with the things that we learn and what attributes do we give. It's not super important. And there's a trade-off in machine learning that you talk about, like overfitting your data, right? You say, hey, this is super accurate. Maybe my algorithm, I'm predicting people like this, but we wouldn't think that learning that Steve is the person not to loan to is the right answer here, right? We'd like to learn something more complex. So there are challenges all through this. We talked about AI and machine learning a little bit. Machine learning and data mining are often thrown around together, sometimes used synonymously. Pushed me, I would say that machine learning is more focused on kind of the algorithms themselves that could maybe make predictions, and data mining is a bigger process that involves kind of talking to the business people, getting data, maybe doing there's lots of work done in machine learning and data mining that's really boring, like writing scripts that go through CSV files and just kind of change the data a little bit, do things like this. It's not super exciting, but it's an important part of the process to prepare it to use a machine learning algorithm to make a prediction or things like that. And then once you can make predictions, what do you do with it? And so there's a whole process of data mining that's involved here. You'll often hear words like big data. And I think more than anything, that's a buzzword that people like to talk about. There's a lot of big data out there in the world right now. I remember I was at a conference and there was somebody from or somewhere like that. He says, you know, everybody talks about big data, but sometimes their big data is what we would call small data because we have big data or something, right? And so people like to kind of throw these terms around and just say, oh yeah, we do big data here. But at the end of the day, there's some truth to that to say everything is being recorded right now. You know, you go to the grocery store and they want you to be part of their frequent shopping club. And why is that? Well, it's so they can track your purchases and your transactions between your visits so they can start to learn about your purchasing habits, right? Because then they say, oh yeah, you would like to buy ice cream. Well, maybe we can send you coupons for ice cream. Or you like to buy pizza after payday, so we can send you our pizza coupons right before payday. Or, you know, you start to learn things about people who buy ice cream also buy root beer. So maybe we want to put the root beer right outside the ice cream at the store. Or maybe we want to put them at totally separate ends of the store so that you have to walk through our whole store to and maybe impulse buy some of our different products as you do that along the way, right? So the business decisions that can be made from that are can be varied, right? What you would do with that, but understanding that can be very valuable. You also have to be really careful. Maybe we'll talk about ethics more later, but there's a story out there, and some people say it might be more than accurate. But as the story goes, there was a retailer that, based on the purchasing habits of one of their customers, determined that she was pregnant and started sending her ads for like cribs and car seats and things like this, right? Because maybe she's buying a lot of prenatal vitamins or something. Well, this really upset the girl's father, who, I think she wasn't married or things like this. And so they said, and demanded an apology. Why are you sending my daughter these, things for car seats or cribs or whatever it was? And, oh, we're sorry, it's some kind of mixed up. Well, then it turns out later, he has to kind of call and apologize when his daughter confesses that she is pregnant. And Target had figured that out before he did, or whatever it was. And so, you have to think a little bit about some of what you do, that either there are questions of ethics, but then there are also questions of, like, creeping you out, right? And sometimes the creeping you out thing is like, well, we'll still give you, put the crib in your email, but we'll put it between a lawnmower and a coffee maker, so that we know you're going to look at the crib because you're thinking about buying one, but you're not going to be totally creeped out by it. So there's all kinds of things that go into this, right? It's not just an easy solution. Within machine learning itself, there are a couple of main branches that we would talk about: supervised learning and unsupervised learning. What supervised learning would be is where we're making a prediction, or we kind of know right answers. And so the way this would work, this would be like my bank example I gave you a second ago. That we have a bunch of data that we know, oh, this person repaid it and this person didn't. And then we're trying to, and then maybe we cover up the last two, say, okay, computer, predict those two and we'll tell you if you got it right. Okay, it implies the presence of this supervisor that can give you the correct answer, or this, I've got a bunch of training data that I can learn the pattern from and predict it. And you'll see this broken into two areas. Classification is where we classify something as fraudulent or normal transaction. This is a terrorist or not a terrorist. This person has cancer or doesn't have cancer. And it doesn't always have to be that. It could be, which type of tree is this based on this leaf, or something like that, right? But this is what we would call a classification problem. We classify it. A regression problem is where we predict a value for something. Like, oh, could we predict what the temperature is going to be tomorrow? If we just say, is it going to be rainy or not, that's classification, but could we predict the temperature? Could we predict stock prices or home prices? Or, I always joke with my machine learning class in the first day, I could write an algorithm that would predict your score and your final grade in this class very accurately. And then you wouldn't have to do any of the homework. I wouldn't have to do grading. We could just give you the grade right now. Oh, I don't know about that, right? And so, but these are the kinds of things that we would talk about as supervised machine learning problems. Then we have this branch that we would call unsupervised machine learning. In unsupervised learning, there's no right answer that we're getting, that we're looking for here. You don't ask questions over here like, how accurate was your algorithm? Accuracy implies a right answer. That means that we're over here. On this side of the world, this is like association mining, or market basket analysis, is the grocery store thing that I gave you a second ago. People who bought this also bought that. Right? There's no, well, now there are ways that we can say, oh, yeah, with 85% confidence, or 85% of the time, people who bought this also bought that. So there are ways that we can quantify how well we're doing, but we don't start out by saying, let's see if we can predict who's going to buy root beer. And then say, oh yeah, look, the ice cream people, they were the ones. But rather just to say, here's a bunch of data, what can we discover here? And often we can come up with interesting things here. Typically, we don't surprise users that much. Sometimes they do. Some of the classic examples of that, we hear people talk about. We find associations between beer and diapers. What's going on here? you start, and then it causes the business people to go in and investigate that further. And maybe they find something like, oh, the wife tells the husband, go to the store and get some diapers, and so he grabs some beer while he's there, or, you know, this kind of a thing, right? But this is something that we can maybe uncover some of these associations, and then how is that actionable? What can we do with that as a business? Clustering would be where we say, you know, we've got, maybe we're looking at, a friend of mine does marketing for sports teams. And so you look at that and you say, wow, we've got a bunch of season ticket holders out there. And we want to better understand our season ticket holders. And what we're going to do is we're going to see if we can kind of segment them into different groups. And okay, well, let's put them in, you know, 4 or 5 different groups, and then say, well, what is it that this group has in common that makes it different from that group? And then we start to look at it and we can say, oh, you know, this is a lot of our people that live locally versus these are the people that live out of town and they're going to fly in. And so then we can start to do things like, well, maybe we want to send them marketing information about plane tickets, or maybe we want to offer these people a 3-ticket package or something like this, right? And we can look at that. And you can tell probably from my bias that I really like the intersection of where machine learning makes an impact in things like business, right? Where is this actionable? What does this do for us? Rather than just saying, oh, I can predict that with 87% accuracy. Just don't go anywhere from there, right? And there's room to do that research. I view that as a means to an end. Why are we doing this in March today? Within machine learning and within this space, especially, I guess, down in this world here of supervised learning, so how do we do this? You know, I talked about, with that bank example, I talked about, oh, we'll find if you're similar to other people. And that would be the basis of one kind of a machine learning algorithm. There's an algorithm, pretty simple, it's called K nearest neighbors. And what it says is you pick some number like K, or K to be some number like 3. And it says, I will take you, I don't know anything about you, but I'm going to find the 3 people in my data set that you are the closest to, and whatever they are, that's what you are. And that makes sense, right? I mean, we can kind of see that in our mind to say, when a new person comes in the door, I'm trying to decide if I do a bunch of tests, and I'm trying to see if they're, you know, at risk for cancer or something like that. But I look at their test scores, and I look at all the people in my database, and I say, boy, they're just like these 3 people over here. 2 of them had cancer and 1 didn't. So if I had to make a guess, I'm going to say you might have cancer or something like that, right? And how accurate is that going to be? Well, you know, we can look at that. We can talk about this. But that's an example of a simple machine learning algorithm. But essentially what this looks like, sorry, it's probably way off here. But we have this black box, in my case, blue. And we want to take and put a bunch of data in this side of the box. And then this is where the magic happens, right? And then out the other side comes our prediction, or comes something like this. And then we put lots of different things in this box. And some of them are better than others on certain problems. Some of them are more complex than others. Some of them tell us why they did that, and others don't. They just spit out a result and say true. Right? But maybe it's really accurate, so you like that. And so what machine learning, a lot of the problem is to figure out what algorithms can we put in this box. And so in doing so, we look at that and we say, well, if we want to make machines learn, how would we best do that? How would we best make machines learn? Well, we look around and we say, we have some examples of things that learn really well, right? Like humans. The human brain, you know, this is an existence proof that learning can happen. And so one approach to machine learning is to try to model the human brain as closely as we can. So we start looking at neuroscience, and we start looking at the brain, and we say, oh, there's these neurons, and they're connected, and they fire at different rates, and we see that the strength between the neurons changes over time based on this. And that's what we look at as a, that's the foundation for this idea of artificial neural networks. Is to say, okay, well, maybe we could build a computer system that mimics neurons in a brain. Because when you get right down to neurons, they're actually pretty simple. They just they get these impulses, these electrical impulses, and then either it starts jumping up and down or it doesn't, or whatever, and there's some kind of a threshold that causes that. And so we look at that from a mathematical perspective, and we say, we can model that. That sounds like, inputs to a function, and then some kind of a threshold that would allow us to output a 0 or a 1. Oh, that sounds even more like computers. And then but where neurons really have this power is when they get hooked together, and there's a billion of them all in sync. And so now we start looking at this and doing this as computer. And so this is what an artificial neural network is. And the field kind of ebbs and flows through what people think are the greatest thing. So people got really excited about this in the 60s, and then there was a paper published that showed that neurons couldn't learn more than a really simple problem. And so it killed the field for 20 years. Nobody did anything in neural networks. And then somebody said, but if we stack them together in this way and put some nonlinear functions in, and we use calculus to figure out how to train them, now all of a sudden we can learn these complicated problems. And so then you have this resurgence, and in the 90s, neural networks were the most popular thing. And then after that, people start saying, well, there's limitations here. And then a new algorithm kind of comes up that has popularity, and then a new algorithm. And there's different things that will come into play here. Interestingly, there's a theorem, this is probably way off, but there is a theorem that, or a set of theorems called the no free lunch theorems. And they say, not that you can't bring pizza to ACM meeting, it says that no one algorithm is going to be best across all problems. In other words, if my algorithm does really good over here, or does really well on this set of problems, that there's kind of this equal and opposite set that it would of necessity do poorly. And then across all possible problems, things kind of even out. And then there's all kinds of people that get into theoretical, kind of looking at that and say, well, it's equally likely to occur in the universe, and things like that. We tend to, people are good at things, and you tend to learn from past experience. So there's something here that says we can learn. But for anyone to just claim that their machine learning algorithm is the best, well, we know that that can't be the case. And so what ends up happening a lot in machine learning is you have a problem before you, and you try to say, well, which algorithm should I pick? And what parameters should I use to do this? And some will be better than others for that problem. As we start looking at what can we do with machine learning, as you guys start to really be good at this stuff, it's like you now have this superpower, right? That you can go and do awesome things with. And so one of the questions is, well, what would we want to do with that? One of the areas that I really like is, and I did a lot of research in the space for my PhD, it's called computational health science. And we said, you know what if we collaborated with these health scientists, these public health people, we could use our superpowers for good or something like that, right? So they have lots of data. They're interested in problems, there's all kinds of medical questions that have lots of data. But then there are things in public health that would be like drug abuse or violence or suicide or some of these kinds of things. And so we said, well, there's a lot of data out there. Whether it's a questionnaire about smoking habits, or one of the things that we thought was really interesting was looking at social media data. Because so often, people would look at the data in public health. And the only way we can figure things out is to do clinical trials or to survey people and ask for their responses, right? And well, it turns out people are putting lots of their information to the world, and Google can predict flu outbreaks way faster than the CDC, because the CDC has to wait for 3 weeks for cultures and labs to come back in and do things, and Google can see in real time when people start searching for flu symptoms and what to do for a cold and whatever. And so, these are some of the classic examples of things that have done well. We looked at some things on Twitter and looked at a few areas. We looked at suicide and suicide risk. And there's some things out there that are really, I don't know, alarming, I guess is the right word. The kinds of things that you see people talk about when people will bully one another, or they will show these kinds of risk factors to say things like, I'm so sick of being bullied. Everybody care about their own problems and don't even bother to check on me. I'm going to go kill myself. Right? And there's some things out there that are really sad. And it turns out that in places like Utah and Idaho, we actually have a really big problem with some of these kinds of. So we looked at it and we said, well, is there any kind of correlation between people talking about this online and actual suicide happening, or in the real world? And because that's a lot of people say, oh, your sample's not representative or whatever. So we looked at tweets kind of around risk factors, people who talk about some kind of known suicide risk factors, and over here in this map, this shows actual suicide rates that comes from the CDC, and it looks at where darker is worse, and it's a per capita thing. Yeah. So darker is a worse problem, and it's the number of suicides per capita. Yes. And then we looked for people who kind of mentioned those terms in Twitter, and for those that we could figure out where they were, because maybe in their profile they said, oh, I'm in Idaho Falls, Idaho, or something. And we looked at that on a state-by-state basis, and we found that there was a strong correlation here, and it kind of gives some credibility to there is a connection between what people are saying and what they're doing. Similarly, we looked at prescription drug abuse, and we started looking at this, and we found a lot of people talking about this medication, Adderall, which is something that can be prescribed for attention deficit disorders and things like this. But there's a lot of talk about abuse of Adderall. People would say, oh, I'm just running on coffee and Adderall or something like this, right? And so we started to look at this, and we looked at this over time, and we found things like, this is the number of mentions of Adderall in Twitter per day. And we would see these kind of spikes each week. It was lower on the weekends and higher during the week. Yeah, the server kind of crashed here, and I didn't realize it for a couple of weeks, so and that's not there. But we noticed like this big spike right here in December, and then again at the end of April and May, we started looking a little closer, and you find that's final exam time around the country. And so we start looking at these tweets, and there are a lot of people talking about abuse of this, of cramming for finals and things, and people asking if they can get it from other people, and or selling it to people, or people talking about again co-ingestion with other substances or things, and that's where it gets really dangerous. It was pretty interesting. We also looked at we said, okay, well, for people who mentioned that, if they also mention things about school or tests or grades, then we have a good sense that they're a student, and then we might be able to look and see if a lot of people tweet with exact GPS coordinates, and we can see kind of what area they're in, and we could normalize that by colleges in that area. So we can put together a map like this that shows, kind of per college student in the area, kind of ranges to see where things are around the country, and that's kind of interesting. And then it's interesting, again, to correlate this with where where this medication, ADHD medication, is actually prescribed, again, coming from the CDC, and to see a strong correlation between these two maps. It's really pretty remarkable, again, showing that there's some potential value in looking at social media data to see not just what people are talking about, but actual behaviors and some reflection of the real world and things like that. There's other things we looked at. This was kind of an interesting study. I won't tell you too much about this, but we built a network of mommy blogs. see what do moms talk about with health. Because it turns out that mothers have a huge impact on the health decisions of the family. Whether or not my kids get vaccinated depends a lot more on what my wife thinks than what I think statistically. And so we went and we looked at these blogs and Twitter accounts. These ended up being, this is a network of blogs, and this is a network of Twitter users. In the green says that person's blog links to that Twitter account, and that's the same person. I had to show you this one because we called this the Rebel Assault on the Death Star graph. but when you start doing that, this is an example of maybe some of that unsupervised learning, that we could start to segment those blogs and graphs and things into different areas based on what they talked about. And so we run this through an algorithm that says what words show up together, and it outputs this thing on the right-hand side. I know this is small and hard to read, but it outputs stuff like this. This is, there's a set of these blogs and Twitter accounts that say baby, birth, pregnancy, pregnant, stories. Yeah, that was HTML stuff that got left in there. Home, hospital. And you say, those must be people talking about pregnancy and childbirth, right? Whereas there's another one that says things like healthy, home, food, chicken, make, family, organic, eat. And you say, well, that's interesting. Those blogs are, right? And you can start to see these clusters. And so you say, there's this cluster of blogs, and people up here that are number 10 that said things like projects and crafts, or this other group of people down 3 and 4 were kind of recipes. And again, that's unsupervised. That's not, how accurate is that, or how right did they get it? As much as now that can help us to go in and learn more about different things. What we love to do in this area of social network analysis is to understand how does a person's network influence them, or how does information spread through a network, right? If there's I want to get information out about the importance of a vaccine or something, who do I want to talk to, and where do I want to spread that message, right? I want to be able to identify the people in the graph that are the most influential. Well, what does that mean? Does that mean the ones that have the most friends? Not necessarily, right? There are different ways to quantify influence in a graph. And so we'll talk about those kinds of things. We mentioned this earlier, but ethics can be a big question that comes into machine learning and data mining. And to say, do people give their consent to have their grocery patterns monitored, or their search things monitored? Well, that's interesting. Or if you could predict, there's movies that get into this kind of thing, but what if I could predict that you were going to commit a crime, but you hadn't committed it yet, right? There's all kinds of interesting topics there. What if we start getting into, our prediction brings things up that we maybe didn't expect, using, race or sex or things like this that we can't discriminate on, but we weren't trying to discriminate on. Is this in our data that it says that these kinds of people are more likely to do this? Or, so there's a lot of hard questions that have to be asked, and that's why I think that it's a great thing to have people like you guys who are good people going into this kind of space. And the same thing, I told Brother Helfrich this about the meeting you guys had a couple of weeks ago about cyber warfare and security and some of those things. In my opinion, we need more good people with good values in some of these spaces to go out and change the world and to do good things with those. So how can you get started if these things seem interesting to you? What kinds of things do you need to learn or know? Well, here's a list of things that are involved in machine learning. So programming is pretty important to be able to do stuff. There's systems that you can use without having to do it, but really learning how to program is super valuable. Discrete math, all of those times when you say, what am I doing this? These are the kinds of things, maybe you can catch glimpses of that as I would talk about things. And it's always fun to, in my machine learning class, we kind of highlight like where are things, we show practical application to lots of the things that you study in these kinds of classes. And so we talk about using Bayes' theorem to do some of these predictions. And everybody's like, Bayes' theorem, oh, we talked all about that in discrete math, and I could work through the problems, but I didn't really see why it was valuable. And it's like, oh, you can use that to do this kind of prediction. You know, and the most popular learning algorithms right now, kind of in the space, the ones that are kind of the most, I don't know, even trendy might be the right word, are these Bayesian networks that they call graphical models, and they show this kind of hierarchy between things. It's all about probability. What's the probability of this given that? And what's the probability of that given that? And I can observe this, so I know that. It's all using some of these kind of concepts that you build up there. You use calculus to do a lot of things in machine learning. There are classic problems that we call optimization problems. And in an optimization problem, you tend to have something like this, and you say, based on whatever my x-axis is here, I'm trying to find the lowest point in this graph, or the highest point in this graph, because that would be the best thing or the worst thing. And now this is pretty easy right here, right? Because this is one dimension. I have an x and a y. But what typically happens is we have lots of dimensions, right? And so, you know, you think about a two-dimensional space with the third dimension being your function that you're trying to optimize. Well, so now there's this surface that I'm trying to find. Or why does that have to just be two-dimensional? So we have n-dimensional space that we're trying to do that. And one of the ways that you look at that is you say, hey, I'm going to go downhill. Well, that's great. How do you compute downhill? Well, that's called a derivative or a gradient in multivariable calculus. And so oftentimes you'll have to get to things where you can go and have a function that can be differentiated and things like this. Now, that doesn't mean that you have to be a calculus wizard to do anything with machine learning, but you can understand that that's part of the space. Obviously, statistics is a big part of machine learning and data mining and things like this, right? To be able to do two things. One is just to speak the language of things like mean and median and standard deviation, and all of those kinds of things are critical to be able to talk and work in this space. But also there's more advanced statistics that come into these kinds of things. Linear algebra and all of these kinds of things come together. Business, we've talked about business and marketing and all this kind of stuff. So it doesn't mean that you have to necessarily be an expert in all of these, but you can see that there's going to be impact, and that's what makes it so fun, in my opinion. That's why, you know, that the computational health science was great, because we're engaging people from sociology and psychology and health and all these kinds of things to solve and do interesting problems. Some of the popular languages and technologies that we use, I would say that of the two languages that are the most common in kind of the data science space and in machine learning, Python is super common and popular. Brother Grimmett talked a little bit about Python last time. R is an open source statistical package that's also used a lot in this space. And sometimes they'll be used in conjunction with one another. Maybe you'll do some initial kind of exploratory stuff in R, and then you'll switch over to Python to write some things. There is some C++ and some Java that goes into some of these things, certainly. But if you just said, hey, what's the language that I need to know to get into machine learning, I would say like Python is a great place to start. It's really accessible, and it's one of the more common things. It's also a great language for doing some of these kind of quick and dirty tasks, like I talked about. This taking data, just having to transform it into a different space, or go through a big text file and, you know, swap out all of the, you know, we were doing some things earlier with some students today that were saying their database didn't handle some of the icons that were showing up in their data set very well. So they had to write a quick script to go through and change those icons to something that it could handle better. And so languages like Python tend to be really good for those kinds of things. There are some, oh, and I should say, in all of those languages, there are going to be open source libraries that you can go use. So even if you don't know how to use what a neural network is really, or much, you can use them because there will be libraries out there that you can plug in and you can tie into. There data that you can get your hands on, there's tons of data out there, whether you like social media and some of the things like I showed you, or you know, the government has a data.gov site where there's tons of data that you can go play with. There are competitions out there. There's a site called Kaggle, Kaggle, Kaggle.com, that is always hosting competitions. And that might be something that we look into for one of the ACM code challenges or something. But some of those have rewards associated, or awards associated with them. Like, you know, the classic one, several years back, Netflix sponsored something, and they said, here's our data. We want you to predict what movies people are going to watch next. And we will give $1 million to the team that does the best job. And as you can imagine, that got a lot of people excited, and they came up with some really clever things, and they did. And they won $1 million, and there was a lot of machine learning research that was done in that process. And there have been other big competitions like that. There are other small competitions for tens of thousands of dollars or things like that. And then there's competitions out there that are just like for bragging rights and stuff. But so there are some things to do that. Resources to get started. I have to laugh when I say this. These are a couple of ebooks that are printed out. Brother Grimmett was printing these the other a few months ago, and I saw it on the printer, and I'm like, who is printing out machine learning with R besides me? I need to go talk to him. So Brother Grimmett's like, well, here, you can have it. So he had it bounded, and I grabbed it from him. But so, and I can give links to these to Matthew that we can post afterward. But we have access to this via our library subscription model to the ebook for free. This one's called Machine Learning with R. This one's called Building Machine Learning Systems with Python. And they will go through and walk you through small examples of how to do that kind of stuff. And they'll say, oh, okay, we're going to predict, we're going to do an OCR task, or we're going to predict, you know, stock prices or something, and they'll help you get a data set and practice doing things. Those are really fun. There is a lot of these online big sites out there, some of the MOOCs like Udacity and some of those have some great courses in machine learning and data science and things like this that I would encourage you to go look at. Some say beginner, some say advanced. Start wherever you are and you can get involved. Here on campus, we have a few different kinds of things. A little bit in this space, we're looking at putting together a data science degree. But there's a class, CS 450, Machine Learning and Data Mining, that I teach. It's a senior level elective. And if you're a software engineering major, it's not on your list proper, but we can substitute that into your list. And so be aware that that's available too. Usually that's taught in the winter. But so there's some things you can do to get started right now. I hope that this is exciting for you, and I guess that's my presentation. So thank you.
Thank you.
All right.
You need
thanks.
this?
Not really, but thanks for the presentation. And does anyone have any other questions or want to bring anything up before we conclude? Thanks.
Any questions?
Sorry, I didn't save time for your question.
So you guys are going to, or someone's going to post these books here.
Yeah, I'll get those off to one of these guys, and we'll make sure they get posted in response to this. But there's tons of online resources. These books are just a couple of resources. Don't consider them as like the Bible.
All right. Well, anything else before we conclude? Or did you want to?
Nope. We have our leadership meeting tonight at 6:15 at the Biddeth building.
Yeah,
And if you want to attend, you can. And we want to thank Brother Burton for coming and giving a wonderful presentation. And we look forward to seeing you guys next week. Next week we're going to cover, I like to tease and say that it's the masochist variant of Linux, but in reality it's, if you actually want to have control over your entire operating system, that's the way to go. So,
All right.
all right.
Thanks again for
See
coming.
you guys next week.